I wanted to make a short video discussing the data types or message types that are supported by MaxMSP. To some degree, all programming languages are defined by the kinds of data, the types of data that they support. So if you've worked with other programming languages, you'll have used integers, floats, doubles, characters, strings, lists, arrays, and so on. And as well as maybe some even much more complicated structures that are supported by programs. So it is important to understand the kinds of data that form messages. So in MaxMSP, there are 5 main data types. The first 2 of those, integers and flow nums, are numerical data types, so ways of representing numbers. An integer is a positive or negative number including 0, but which has no decimal points, no floating points or decimal point precision. So if you are performing operations for which integers are going to suffice, then you can use integer objects. For example, a MIDI note. Well, in the MIDI world, 60 is the pitch for middle C and 61 is the pitch for C sharp. But in MIDI you can't send 60.5 or 60.25 or 60.0013. The system won't understand it. It doesn't support it. So there's an instance where you would use an integer rather than a floating point number. A floating point number has decimal places, so it allows much more precision. If you're doing calculations which involve multiplication and especially division, you will want to ensure that you're doing your calculations with floating point numbers. If you divide 5 by 2 and you are using integers, you will not get the correct answer because the correct answer of 2.5 cannot be represented as an integer. And we will get into that in more detail later. So on this Max patch, you can see that first of all I have a print object with the word data, and whatever comes into this print object will be printed out in my console. So let me open up my console. This is the Max console. I'll open it there, clear it out, and if I type in here and put 15 and hit return, the value of 15 is displayed there. And if I put my mouse in this number box and move up and down, you'll see all the values are printed out the moment I move my mouse. Similarly, the floating point number box, I can click in this and I can move it up and down, and you'll see that rather than just printing 13, it prints 13.000000. And I can click over here and I can move tenths and hundredths, and if my box was bigger I could put thousands and tens of thousands and so on. So I can have a high degree of precision with a flow num box. Now I mentioned before that dealing with, you have to be careful deciding whether you're dealing with integers or floating point numbers. Let me type an F, Command E to get into edit mode, F to bring out a floating point number box, I to bring out an integer box, join the 2 of them together, Command E to go back into performance mode, and you'll see that if I do this and I move my floating point number up, this makes sense. A 5.0000 goes into an integer box as 5, but look what happens if I click over here and I say, well, what does 5.8 when it goes into an integer box become? Well, it becomes 5.0, and I can go all the way up to 5.99. That when it's put into an integer box simply becomes 5. So you can see if I were doing calculations here with integers when I needed floating point numbers, I would not be getting correct results. Okay, so those are the 2 numerical data types. We have symbols, and symbols are reserved words that particular objects understand. So it turns out I've got one here. This object called clocker counts every whatever this argument is in milliseconds. So every 100 milliseconds it will put out the time. And I turn it on with a toggle box. And so let's do that, and we'll see that it's going up in hundreds. Every hundreds of milliseconds it puts out the current time. But I can reset it by sending the message reset into it, and it will restart the counter every time I click it. So that's an example where a particular object understands a particular symbol and will respond to that symbol in a particular way. So symbols tend to be words like clear, start, reset, and so on. And you can't simply decide that an object wants to have a particular symbol. They have to be specified as something that that object deals with. If I, for example, go here and click on the clocker, so it's highlighted, and I go to reference, I can find out information about the clocker. And if I look down here, it tells me what various messages it can receive. It can receive a bang, an int, a float, a list, anything as a list. It can also receive a clock message, a reset message, and a stop message. Right? So once I know that, and go back to my console here, I know that I could also have a message which was stop. And I could put that into my clocker. And I can start it here, and I can stop it with that message. Okay. So, symbols. The next data type that Mac supports is a data type called a bang. And a bang is normally created with a bang box. By typing B, you create a bang box. Also, you could type a message which says bang in it. That would also work. And a bang is not an integer. It's not a floating point number. It's not a symbol. It is a particular message which tells an object to just do whatever it's supposed to do. It's kind of like a wake-up call, or someone, tapping you on the back and saying, okay, do your thing. Often an object will simply put out the last value that it output before. So think of it as a kind of an instigator of action. Do something, anything. Okay, and we'll see instances where bangs behave differently than integers when they go into an object. And the last data type is a list. And a list is a sequence or a collection, an ordered collection of any of the above data types. So it can be a collection of an int, a float, and a symbol, or 4 ints, or they can be any length, and they're simply put into message boxes with spaces between them. So we have two messages here. This one is 3 integers. If I click on it, you'll see that it prints out 10, 100, 1,000, and this is a floating point number, a symbol, and an integer of 34. And if I click on that, you can see that it prints out that data. So lists are particularly useful for situations where you want to collect your data together because it is logically connected, and you want to pass it around from one object to another as an entity. So for example, let's say I was trying to represent a musical note, and I decided that I needed that note to have a pitch and a velocity or volume and a channel and a duration. I might make a list of 4 elements that stores all of that information, or that represents all that information, and then I can simply pass it around as a block rather than individually passing around the pitches and the velocities and the durations and the channels and running the risk that they get mixed up. Okay, and we'll see instances where it becomes very useful to build a list out of a bunch of components and then pass them around from object to object as a list. So those are the 5 data types that we'll be using in the first half of the class. There are a couple of other data types that we'll be looking at later in the class. The first of those is a signal, which is a way of representing and passing digital audio from one object to another. Signals, or sometimes called signal tildes, are actually floating point numbers, but they have the characteristic that they're generated constantly at the sampling rate of your system. So 48,000 times a second, all of these signal objects are updated and produce values. So it's a little different than the max floating point numbers, which only pass messages on when they are triggered to do so. So here we have, and I should mention that almost all the signal objects, probably all the signal objects, have this little tilde at the end of their name. So a cycle tilde is a signal type object. A multiply tilde is a multiply type object, or sorry, is a signal type object. So if I turn on the system, the audio system, by clicking down here on the audio on off, you'll hear a cycle. It's actually a sine tone at 440, and there it is. Very exciting. And I'll just turn that off before it drives us crazy. And the last data type that Mac supports is a matrix, which is a multi-dimensional array, and it's primarily used to hold video data. I'm not going to go into too much detail right now. It's something we won't be looking at until we get very near the end of the course. But actually, you'll notice, I should have mentioned that the signal objects have different patch cords coming out of them. And the matrix objects have different patch cords as well. These are green and black, that's yellow and black. And so this particular object is an object that plays videos. It's going to play a video called chickens. And this is an object that will can be used to view videos. So if I turn this on, you'll see the chickens coming out of the chicken coop. I know you can't see that all that well, but they are coming out. One just fell off. And there we go. So as I said, we won't be dealing with that for a while in the course, not till the very end of the course. So we'll be starting to deal with signals probably in week 7, video more like week 12. These data types, the first 5, you'll be using right away, or almost right away. So it's important to understand the integer, flow num, symbol, bang, and list.